Here are your slope field notes for those of you who are taking AP tests, but need to know about slope fields. So first I've got this slope field visual. I'm not going to look at this here because it's too hard to go back and forth, but I do want you guys to take a look at it. Basically what it's going to do is it's going to let you know if they give you a dot, like let's say for example they say draw a function that goes to the point 3.5, 3. You just need to know that you are following along kind of the tangent line plan, which kind of leads me into the next thing. So see, this is like a circle. So think tiny it's just tiny tangent lines. Think about little sticks going or going with the flow of the river. You want to move with the flow, not against the flow. So you don't want to like cross, and cross one of these tangent lines. You want to go with the tangent line and go around in the circle. Now you don't have to be perfect because it looks like I'm a little off. Really, my circle should go a little bit further around. But as long as you get the general gist, if they were to ask you that on a free response, you would know what to do and be okay. All right. It's a little more clear. Right here. Remember, tangent lines represent the derivative, which represents the slope of the tangent line. So each little line is a new version showing you the slope at whatever point that you're at. So whatever XY point that you're in. So for example, if you had the derivative is equal to negative x over y, the slope field would look like this. Without this dot and this circle, that wouldn't be there. It would just be a big field of little sticks floating around a circular pond, I guess, because maybe there's like a sinkhole in the middle and it's swirling around. Now, I'm going to show you a couple different ways of how this all occurs. So all of these little tiny tangent lines are just representing what the picture would look like at some C. We don't necessarily know what C is. So we're going to do the differential and solve it. Okay, cross multiply, we've got y dy, cross multiply, negative x dx. Integrate both sides, you get y squared over 2 on the left, you get negative x squared over 2 on the right, and then you put in your plus c. Now, we want to know what this thing looks like. We'll multiply the whole thing through by 2. You don't have to multiply the c by 2 because it's some constant, and some constant multiplied by 2 is still some constant. And then c, which is just a circle. So the derivative comes from the equation of a circle, which is why the slope field looks like a circle, because the function is a circle. To find the match. We can find the match by putting coordinates into the derivative and determining the slope and matching it that way. Now, a couple of things that I look at. I look at horizontal tangent lines. Look at right here, we've got horizontal tangent lines. So when x is equal to 0, we have a horizontal tangent line. Well, that makes sense, right? If x is equal to 0, then the numerator is equal to 0. So you're going to have a horizontal tangent line where x is equal to 0. When y is equal to 0, you're going to have an undefined slope. So when y is equal to 0, all along here, this should be vertical because you've got a vertical tangent line. So you're going to be vertical. AP really focuses on. Sometimes you can answer questions just by knowing where vertical and horizontal tangent lines are. Now, further. Okay? Let's say we're in quadrant 1. Here's quadrant 1, right? Quadrant 1. In quadrant 1, x values are positive, your y values are positive. X are positive and y are positive. Well, if we're looking at our differential, negative x over y, with a negative positive over a positive, that means you're going to have all negative slopes. Quadrant 1, all your slopes are negative, and they are. Now, there are all varieties of negatives. So, like some of your steep are not as steep and a little more flat. Okay, it just depends on where the coordinates are and how they go into the spot. Now let's look at quadrant 2. Here's quadrant 2 over here. Quadrant 2. In quadrant 2, your x's are negative, your y's are positive. X negative, y positive. All right, well, if you put in a negative at the top and a positive at the bottom, we have a negative negative over a positive. Well, a negative negative is a positive over a positive, so you're going to have all positive slopes. In quadrant 2, all of your slopes are positive. They have different slope sizes, so one might be 1, another one might be 10, another one might be 1/3, but they're all positive slopes. Let's look at quadrant 3. In quadrant 3, x is negative because you're going to the left. Y is also negative. So if you have a negative negative over a negative, that means you have all negative slopes. Which we do right here. All of these slopes are negative. And then, of course, it should be 3. In quadrant 4, which is this last one right here, your x's are positive, your y's are negative. So again, we have negative positive x over negative y. The negative negative will make it a positive, so you'll have all positive slopes, which of course we do. Now, that's going to help you when you have to do matching. Okay, you are going to have to do some matching, which we'll do a little bit later in our lesson. It will make a little more sense as we go through our lesson. Okay? All right, so what we're going to do is we're going to practice drawing the slope field. Because if you know how to draw the slope field, then that's going to help you understand what all the slope fields mean. Now, on an AP test, they give you a variety of different dots. Sometimes they give you 12 dots. Sometimes they give you 20 dots. Sometimes they only give you 6 dots. However many dots there are, you have to fill in differentials for each one of them. Now, when you're doing this, the point values, they focus on where the horizontal tangent line is. Usually you get a point for just saying where the horizontal tangent line is. And then after that, they're looking at, okay, do you know where the positive slopes are versus where the negative slopes are? And then they wouldn't want you to have like a slope of 5 being more steep than a slope of 1/5. But other than that, you're not going to have to get a protractor out and figure out what exactly the slope might be. But you do have to estimate the slope, figure it out, and then draw it. Okay? So, let's take a look. Now, when you have a differential, we're not going to solve the differential. We're just going to draw the tangent lines. So we're going to draw the slope. And x in the problem, that means they're going to be the same vertically. Because if I'm doing the point 1, 0, it's not going to be any different than 1 or 1, 2, because I'm not putting in that y value. So 1 negative 1 is the same, and y negative 2 is the same, because the y's aren't changing the slope. So vertically. And x is equal to negative 2. My slope is going to be negative 2 plus 1, or negative 1. Negative 1. Well, then I have a negative 1 plus 1, so my slopes are going to be 0. If I put it equals 0, I have 0 plus 1, so my slope is 1. If x equals 1, 1 plus 1 equals 2, and if x is equal to 2, 2 plus 1 is equal to 3. So what I'm doing is I'm going to draw the slopes of these little teeny tiny tangent lines. Okay, so when negative 2, all my slopes are negative 1. So I'm just going to draw all of my slopes somewhere around the negative 1. Now, I'm guessing. I don't know if that's a slope of 1 or not. I'm just estimating and making that my slope of negative 1. Make sure it's negative, so it's rising to the left or falling to the right. Now, when x equals, all of my slopes are 0. Again, this is huge. Horizontal tangent lines always get you a point. When x is equal to 0, my slopes are all 1, so I have a positive 1. When x equals 1, my slopes are all 2. Well, 2 is going to be a little more steep than 1. Now, again, I'm not going to go through and try and, take forever figuring it out. I'm just making it a little more steep. And then 3 is steeper than the 2. So again, you're just going positive slopes. You're just estimating what it is. Now, it looks like this is going to be some sort of a parabola. You can see the parabola kind of working here. Okay, so if they tell you, what does the graph look like if you know that the point negative 1 is on the graph? Well, if they put the point negative 1 on there, you just follow your tangent lines. When you follow your tangent lines, then you've got what your picture looks like. Derivative equals 2y. Now, when the problem, and when you write the x's, where you are on the x-axis doesn't matter. It just matters where you are on the y-axis, which means that everything is going to be the same horizontally. So we say when on the y, it's going to be the same horizontally. Now, this just saves you some time. And you'll see what I mean when we look at number 3 and number 4. Number 4 is the work. Y is equal to negative 2. Well, then I have 2 times negative 2 is negative 4. Y is equal to negative 1. That's 2 times negative 1 and negative 2. Y equals 0. Oh, those are my horizontal tangent lines. Y equals 1. My slopes are 2. When y equals 2, my slopes are 4. Here are my slopes. Y is equal to negative 2. All of my slopes are negative 4. Well, negative 4 is going to be a pretty steep slope. And my slopes at y equals negative 1 is negative 2. Well, those are going to be a little less steep. Then at y equals 0, I have horizontal tangent lines. Now, I know they're kind of hard to get in there, but just draw them the best as you can. When y equals 1, equals 2, you have a positive 4 slope. So it's more steep. Okay. So you're just drawing in your slopes, little teeny tiny tangent lines. All right, now 3 and 4 are the ones that are kind of a pain in the butt. The reason they're a pain in the butt is because x and y changes. So let's take a look. When you're doing this, I'm going to show you some examples just to get you started, and then I'm going to fill in the rest so you can see what the picture is. Okay? Let's say 0. If I start at the point 0, 0, I have 0 plus 0 equals 0, because my derivative was x plus y. So that means that, okay? Now, let's say I pick the point 1, 0. Well, that's 1 plus 0 equals 1, so I'm going to have a slope of 1. Let's say I pick the point 2, 0. So that's 2 plus 0 equals 2, so I'm going to have the slope 2. Now, so I pick the point 0, 1. Well, that's 0 plus 1 is 1, so I'm going to have a 1 again. Okay. Then I pick 1, 1. Well, 1 plus 1 equals 2, so this is a slope of 2. Now, you're just going to keep on going through this, picking all of these points. Let's pick a negative one. Let's say I have negative 1, or positive 1. When I have negative 1 plus 1, that's 0. So I got another 0. Now, you are going to find some patterns. Now, here, it's interesting. They're kind of the same along the diagonal line. So we're going to be the same right there. Let's see, these are all going to be the same. They're going to be slopes of negative. Then we're going to have them a little more steep. And then they get a little more steep. And then they get the most steep right there. These diagonals are all a positive 1. Then we've got the positive 2. Then we've got a little more steep and a little more steep. And this one's like that. So, this one. This is the point 0, -2. So your slope is a -2. So it's steep right there. A little while, yeah, I did. We're going to see an AP question, and we're going to show you what it is that you need to do. But let me tell you that usually 2 points. Your first point is going to be where the horizontal tangent lines are. So if you're running out of time, you're just going to do the horizontal tangent lines and move on with your life. Now, if you do have time, then plug in all the points. Find all the little slopes and draw your picture. Like, what they're doing is they're going to give you 1 point if you had positive slopes everywhere they should be positive and negative slopes everywhere they should be negative. All right, let's look at number 4 because it's the worst. I really, really, really hate number 4. So for number 4, we're going to be undefined. But if y is equal to 0, then you're going to be equal to 0. So if y is equal to 0, you're going to be 0. If x is equal to 0, you're going to be undefined. This is 0, 0 is an undefined spot. There you go. And now you just have to start picking your points. Woo! But look, you only have 4, 4, and 4. I mean, that is a lot. But you just do what you can. All right, this is the point 1, 1. So we put in the point 1, 1, and we get -1 over 1 is a -1. So you have a -1 slope. Okay? Then you pick this point. This is the point 2, 1. So you have a -y over x, so a -1/2. Well, that's going to be a little less steep. Okay? Then you have the point 1, 2, which is going to be a -2 over 1, so a -2. And then we have the point 2, 2, which is going to be a -2 over 2 or a -1 again. Okay? Now, you're going to do that with every single one of those points. Now, do you have to show your work? No, you can do it in your head. You don't have to show your work. You just have to show the pictures. So I'm going to go ahead and put in your slopes. You can see more of my work on the answer key. And I'm just going to draw in just to save us some time here. Right here. Again, they're really only looking for positives where positives should be, negatives where negatives should be, horizontals where horizontals should be. So hopefully this kind of helps you a little bit with how they're doing all of these points. So like what they did right here, let's say they have this point 2, 3. Okay, and we're right here in this point 2, 3. Well, if we put a 2 and a 3 in here, this is -2 over 3, which means we have a -2/3 slope. And again, remember you're just estimating, so that looks like a negative slope, so that's where it comes from. Let's say we've got like a point down here. Let's say 2, -3. Well, 2, -3 is right in here. All right, so that's a negative. +2 over -3, that's going to be a +2/3. Well, a +2/3, we're going in a positive direction. So that's all we're doing to make all of these little teeny tiny lines. Page. So remember to focus on where the horizontal tangent lines are, because that's 1 point, and then focus on the positive slopes versus negative slopes. That's your other point. Now, you could get some multiple choice problems. So let's take a look at this matching problem. This matching problem says, okay, here's a slope field. Go ahead and match it up with your differentials. So we need to look at how we're going to solve that kind of problem. Now, I'm not going to start picking them all into every single one of these. That would take forever. Instead, what I'm going to do is I'm going to say, okay, let's look at quadrant 1. Okay? If we're in quadrant 1, x is positive and y is positive. So if we're looking at our combination here, what kind of sign would we have? So if my x is positive, y minus x, well, I'm going to have a signs in there. If y is bigger than x, then it'll be positive. If y is smaller than x, then it'll be negative. So we're going to have a mix of positives and negatives. Now take a look in quadrant 1. We have positive slopes over here. We have negative slopes over here. Okay, so A is still in the contention. So you're going to have a mixture of things. Okay? X is bigger, it's positive. If y is bigger, it's negative. Let's look at C. If we have x is positive and y is positive, x over y is going to be all positive. If it's all positive, C is gone. Okay, because it can't match that picture because some of those slopes are negative. Same thing with here. Part D, those are all positive as well, so we get to cross those off. Now in part E, a negative positive over a positive is all negative. Well, we get to cross that one off as well. So just by looking at our quadrant 1 information, we were able to figure out what was going on. And now we've got a 50-50 shot. So now we're working quadrant 2. X is negative. And y's are positive. And x's are negatives. That's y minus a negative. That means in quadrant 2, I'm going to have all positive slopes. But look at these. Positive, these are all negative. Here's your answer. Let's just double check real quick. If you have a negative x, so negative x minus a positive y, so negative x minus y, that will be all negative, which is what you've got going on. So again, we know B is our answer. Now we're going to also spot check it. Negative 2. Okay, look at right there, negative 2, negative 2. That should equal 0. Minus a negative 2, that's going to equal negative 2 plus 2, which equals 0. So yeah, by spot checking it, you got that one right. Now you can spot check as many as you want. Don't spend too much time on it. The quadrant thing makes you go. Now let's look at number 2. Number 2 is a little trick here. Because look, all of these are derivatives, but all of these are derivatives. All of these, and then I went back to what I did with number 1. So I said, okay, dy dx of sine x is cosine x. The derivative of cosine is negative sine. The derivative of 1 over x is negative 1x to the negative 2. Make this x to the negative 1 and do your power rule. Dy dx of negative 1 over x is a positive 1, x to the negative 2. And the derivative of ln x is 1 over x. Okay, so this is negative 1 over x squared, and this is a positive 1 over x squared, because this one is a negative x to the negative 1. So when you do the derivative, you get positive 1 x to the negative 2. My derivatives, which weren't all that hard to do. So let me look at quadrant 1. Quadrant 1, we've got positive, x positive, y positive. Right off the bat. We know that cosine and sine make the cosine sine wave. So you're going to have some variation of a wave in order for it to be some sort of sine or cosine. So these are gone, because this isn't a wave. This is kind of like going in kind of like a funnel. Is positive, or if x is negative, is it going to make any difference? No, because that doesn't work over here because these are positive slopes, so C is gone. These are going to be all positive slopes because no matter what x you're plugging in, we're always going to be positive and a positive on top, and that's gone too because these are negative. And here we go. 1 over x is our answer. Now, you know it's our answer because when x equals 0, you're going to be undefined. Okay, which makes sense. Oh, hey, look, it's going towards some asymptote. When x is positive, you're going to have positive slopes. When x is negative, you're going to have negative slopes. You found your answer right there. AP question. Okay. So, I have the square guidelines with us as well, but let's take a look at this AP question. I actually suggest you hit pause right now. Give this AP question a try. This is from 2004, non-calculator question number 6. We're going to take a look at it. Now it says, on the axis provided, sketch the slope field for the given differential. Use the axis provided in the pink test booklet. So you're actually going to draw in your test booklet. So, all right. Again, I'm just picking my points here. So I got x squared and y minus 1. So I just started picking my points. Now I'm not going to write all the things down. I'm just going to give you the answers. So you have a 0 slope right here. You have a 0 slope right here. You have negative 1 right here. You have positive 1s right here. And then you have positive 2s right there. And there are your slopes. Okay? Again, if you're kind of stuck, then when you come in on Thursday, talk to me and we can help you figure those out. That's it. We're going to talk about how we score those in a minute. Part B. The slope field in part A is drawn only at 12 points and is defined at every point in the xy plane. Describe all the points in the xy plane for which the slopes are positive. Okay? We'll take a look. This is always going to be positive as long as it's not 0, right? So x cannot equal 0. This positive as long as y is greater than 1. Because if it's less than 1, it's going to be a negative. If it's greater than 1, it's going to be a positive. If it's equal to 1, it's back to 0, and that's no good. So it's when x is equal to 0, or not equal to 0, and y is greater than 1. So I'm going to put that in here for part B. So you're going to have a positive slope when x cannot equal 0 and when y is greater than 1. That's all they're asking for. All right, let's look at our next one. Part C. Find the particular solution, y equals f of x, to the given differential equation with the initial condition 0, 3. So now you're doing your differentials. This is where you are separating your variables. You're doing your x's with your dx's and your y's with your dy's. So I pulled it down a little bit so you could see this again. This is going to divide, so it's going to be below that. This is going to multiply. So I'm going to end up with dy over y minus 1 is equal to x squared dx. Okay? I'm going to do my differential. So the first thing I want to do when I'm doing my differential, separate my variables, which I just did, and now I'm going to integrate both sides. Now, this kind of needs a u substitution. Now, I say kind of needs a u substitution because when you take the derivative of it, it's just equal to 1. So it's just going to be 1 over u du over 1, which really isn't going to change anything. It's just going to be the ln of u. ln of u. 3. Then we have our plus c. Okay? It said f of 0 is equal to 3. But here's the problem. If I put for y, I get the ln of 2. It is. Now, could ln of 2 just be? Yeah, I'm looking for though. And so since I don't know the ln of 2, I'm going to see if I can't solve for y a little bit more and see if that helps. Now, when we solve for y, change your ln to log base e. I'm going to come over here. I got e raised to the x cubed over 3. Now, I would put the plus c, but remember that becomes a big C in front, and that's going to equal y minus 1. Now, when I plug in my 0 and my 3, I don't have to worry about that ln anymore. I've gotten rid of the ln, and now I can solve for c. So I've got c, e to the 0, x is equal to 0, equals 3, y is equal to 3 minus 1. Well, e to the 0 is 1, so that means c is equal to 2. So I get 2, e to the x cubed over 3 equals y minus 1. And remember, you need to solve for y. So you just add your 1 over. That's a 3. So y is equal to 2, e to the x over 3 plus 1. All right, we're almost done. Let's just take a look at where all the points came from, and after that, we'll be done with this portion. So in part, notice it's a 2-point question. Like I said, you get 1 point for where your 0 is, okay, where your horizontal tangent lines are. So if you have only a little bit of time, just put in your horizontal tangent lines and move on to the next one, okay? You get 1 point knowing where the positives and negatives are. If you even miss 1 dot, I think they take that point away. So it's so much easier just to move on and do the other problems. Come back to that of time at the end. Okay? All right, part B. We get 1 point. Slopes are positive at the point x, y, where x is not equal to 0 and y is greater than 1. We talked about that. You get 1 point. Great. Now, remember where the points come in. Take a look at this one. This differential question is worth what you can get. We really only need you to get 4 per problem. So we're getting 6 points. We have a differential equation problem. So the first one is separate variables. So you separate your variables, which we did. Now note down here, 0 out of 6 if you don't separate your variables. So you have to separate the variables. That's step 1. Now this one, remember sometimes I told you they gave you 1 point for doing the integration. This one in particular, they gave you 2 points. So you get a point for this integration and you get a point for this integration. And then we wrote this a little different. We wrote x cubed over 3, and that's perfectly fine. You can do that. Now, you get a point for adding in your plus c. We talked about that. Crazy. So you got 4 points right here. That was and you want to plug in your initial condition, which was 0, 3. If you plug it in, you get another point. So even if you couldn't solve for y, and even if you plugged it, let's say you plugged in here and you got stuck, right? You're already at the 5 points. And then the 6th point is if you solve for y. 0 out of 1 if it's not exponential. So you need to have the e in there. So if you don't switch it over to e, then they're not going to give you that final point. So if you leave it in just ln's and stuff, they don't like that. So you gotta switch it over to e. Also note down here, you can only get a max of 3 out of 6 if you didn't put the plus c in. So you would only get these first 3 points. But we will remember the plus c, right? Because that's like a free gimme point. So that's where your 6 points come in. All right, great. I hope to see you Thursday. All right, bye guys.